Good morning and welcome to this video for Logic and Philosophy, HUP 112. My name is Dr. Richard Brown, and today in this video what I want to be doing is continuing our beginning exploratory discussion of logic, and we're still exploring the first chapter of our textbook. This is the chapter entitled Basic Concepts, and the textbook is Hurley Logic, the Essentials, which itself is a kind of condensed or smaller version of the classic text Logic, A Concise Introduction, by the same person. So in this one, we're continuing to work through chapter 1. We're now in the section 5 of chapter 1, talking about talking about argument forms and proving invalidity. So as before, I want to work through some examples in the textbook, and what we're doing now is talking about counterexamples. So we've been working our way up to discussing exactly this. Now, what we'll be giving is an argument in English. So here's an example from the textbook. It says all galaxies are structures that contain black holes in the center. So all galaxies are quasars, since all quasars are structures that contain black holes in the center. So this is clearly an argument. You see the indicators so and since telling us where the conclusion and the premises are respectively, and so we're going to represent this in standard form. But the question that we want to know is this valid or not? So in the last videos, we were sort of just relying on our intuition. Can these premises be true while the conclusion is false? But now we're going to develop a method, the method of counterexamples, which was first formalized by Aristotle. And the method of counterexamples really exploits basic ideas that we'll be exploring later on in the class. It involves a little bit of creativity, and so you want to get a feel for it. We definitely will be doing counterexamples in the class on exams and in quizzes and stuff like that. So this is something you want to be able to do. Now, rather than just rely on your intuition about these premises, are they true or false? Because, are all quasar structures that contain black holes in the center? Well, you could Google that and find out. But actually, what we're more interested in is the structure that this argument pattern, this exemplar of some kind of reasoning here represents. Is it a good reasoning or is it bad reasoning? Turns out that we know that this argument is invalid, and the task that we're given is to prove that it's invalid. And the way that you prove that it's invalid is by recognizing that it's the form of the argument which really gives it its validity, and then you want to see whether or not that form allows the possibility of having true premises and a false conclusion. So let's go ahead and work through this step by step. So the first thing to do is to identify the premises and conclusion, and so we did that already. The next thing to do is to try to represent this in standard form. So we want to take it out of the English, write the premises that are numbered, and then translate it into a kind of semi-symbolic structure that allows us to see what kind of form the argument has. So the first thing we want to do that is generate a key, and by that doing that, we identify the things which are repeating throughout the argument. So we see galaxies and structures that contain black holes and quasars, and so we'll pick capital letters to stand for those things. I'll use G, S, and Q because for the obvious reason. But remember that it's totally arbitrary, and you could have picked different letters like A, B, and C. S, P, and M are kind of traditional for subject, predicate, and middle term. And if you want to know more about that in chapter 3 and 4 of our textbook, it's completely devoted to categorical logic, which is the logic of categorical syllogisms, which is what we're looking at here. So this is an example of a categorical syllogism. We'll talk more about this throughout the class. But now, if we take the argument in the standard form, using the letters that we have here on the right-hand side, then the first sentence, all galaxies are structures that contain black holes, can be written as saying that all G are S, where G and S stand for things which are galaxies and structures that contain black holes. Notice that I had to add things which are galaxies. There are different ways of doing this, and this is kind of a generic way. Chapter 3, they explain different ways, more in line with English. This sort of is a weird thing. But in categorical sentences, what you're doing are talking about the relationships between categories of things. And in English, you need a noun phrase. Usually it's plural. And so galaxies is just a noun, and maybe someone would know that you were talking about the category of things, which are galaxies, objects, which are galaxies, um, astronomical bodies, which are galaxies, whatever it is that you are talking about here. But I just use things, which are as a generic way of making this into it. So if you really wanted to read the sentence, it'd be all things which are galaxies are structures that contain black holes in the center. Okay, so that's what the first sentence would say. Now the second sentence is really the conclusion, and we know that because of the word so right there. So the last sentence, that following since, is really the second premise, and it says all quasars are structures that contain black holes in the center. Therefore, we would represent that as saying that all Q are S. And then we draw our line indicating that the thing that follows it is the conclusion, and now translating the conclusion, all galaxies are quasars, that's all G are Q. So now we have the argument form. We've taken the English, we've taken the particular things that the argument is talking about, and replaced them with just placeholders for categories of objects. And now we can see what the sentences, the propositions, what propositions these sentences are really expressing. So they're expressing these categorical statements, relating these categories of things, G, S, and Q. Now, we know that this is an invalid argument. We were told that at the beginning. And since we know that this argument is invalid, then what that means is that it's got to be possible to think of something that G, S, and Q could stand for, some categories of objects, which would reveal that the premises actually could be true while the conclusion could be false. Now, we've seen this pattern before. This is one that we'll see a lot. This is a kind of classic invalid pattern. And if we let G stand for things which are cats, and S stand for things which are animals, and Q stand for things which are dogs, then rewriting those sentences will reveal the counterexample that we wanted. So for instance, taking now G to stand for cats and S for animals, notice we could have went back and rewritten that to say that all C are A and all D are A, therefore all C are D. That's be the exact same pattern. So which letters we actually use doesn't really matter, which is why I've chosen to just keep it the same. So then continuing, using now our Q and S, the second sentence says that all dogs are animals. And of course, using the same key right here, we can see that the conclusion now says that all cats are dogs. So we know that that's false. And I now make my trademark joke that there's only one cat, which is a dog. That's cat dog. So that joke is getting a little bit old. I've made it a billion times, but I'm obligated to make it when I use these kind of counter examples. Okay, so there it is. Now notice that we have now shown definitively that the argument pattern, the argument form that we had written up there before, all G are S, all Q are S, therefore all G are Q, is invalid. That form of reasoning is an invalid form of reasoning. It allows the possibility of starting from true premises and ending up with a false conclusion. It may or may not have been the case up here, although it is in fact false that all galaxies are quasars, and probably also false that all quasars are structures that contain black holes in the center. So in that particular case, we might have been able to show that the premises were false, but even more dramatically, what we've now shown is that it doesn't matter if those premises are false or not up there, because there is no logical connection between those premises, the categorical propositions which are expressed in statements 1 and 2 up there, and the conclusion. They are not logically related as the counter example shows. They are just 3 sentences up there, and someone has claimed that if the first 2 are true, then the last one must be true, but it doesn't have to be true. We've now shown that relationship doesn't hold, and therefore we have proven that the argument form is invalid. And since the original English thing can be interpreted as having that as having that form, then we have proved that the original argument is also invalid. Now, importantly, please keep in mind what that means. When you show that an argument is invalid, you don't show that the conclusion actually is false. So it may be true that all galaxies are quasars is false, But if it's false because of things about galaxies and quasars. It's not false because of the argument that we have been examining. What we have shown is rather that there is not the relationship which was claimed to hold between the premises and the conclusion. They don't support that conclusion. So that's what we show, that there is no support, no logical relationship between, or at least not the claimed logical relationship um, of support that holds between the set of sentences and the premises and the sentence, which is the conclusion. So that is different than showing that you know that the conclusion is false. The conclusion may be true for other reasons. What we have shown is it's not true because of these reasons. And that's important for people to understand, that when you show that an argument is valid, what you've shown is that if the premises are true, then the conclusion must be true. To show that the argument is invalid is just to show, well, that it's possible that the conclusion is false while the premises are true. It does not show that the conclusion is actually false. Okay, and just to illustrate something which is important here, that the idea that of the formality of what we're doing here, let's just take this argument form which we were just looking at. So premise 1 and 2, as they were on the previous slide, the conclusion is the same. What would happen if we just take the conclusion of the previous argument form and swapped it with the first premise? So whereas all G or Q was previously the conclusion, let's make it the first premise. We'll keep the second premise the same, all Q are S, and then in the conclusion, we'll have what was previously the first premise, all G are S. So now we have produced a new argument form. It's not the same argument form as before. We've changed it. It certainly is not the argument form of what was written in the English, given the words so and since and their meaning. So if you had mistaken the premise and conclusion in that argument, you may have written something like this. And if we kept the same key that we had before, remember this is the one which showed that the argument pattern on the right-hand side is invalid. So in reading it that way, the pattern on the right-hand side says that all cats are animals, all dogs are animals, therefore all cats are dogs. And we know that that shows, that's the counterexample to the previous argument pattern. But what happens if we take that exact same key and put it into this new thing that we have produced on the left-hand side? So the first sentence would say that all cats are dogs, because it says all G are Q, and G is things which are cats, and Q is things which are dogs. So that's what the first premise would say. The second premise would say that all dogs are animals, because it says that all Q are S, and now Q stands for things which are dogs, and S stands for things which are animals. And then again, following that very same pattern, the conclusion would say that all cats are animals, all G are S. So now looking at that, you ask yourself, is this still a valid argument? It's not the same argument as before. It's not the pattern on the right. It's not the pattern on the left. And that pattern actually is valid. That is a valid pattern. You can see that if it's true that all G are Q, and if it's true that all Q are S, then it has to be true that all G are S. And I won't go belabor that point, but that is a valid argument. And so, well, what happens when we put that key into it? Well, you can see right there that the first premise turns out to be false. What was previously the conclusion is now the first premise. It's still false. All cats are dogs is false. But that is a valid argument, because if it were true that all cats are dogs, and if it were true that all dogs are animals, then it would be true that all cats are animals. It so happens that the first premise is false. And so therefore this argument is not sound. It's valid but unsound, and therefore doesn't give us any reason to believe the conclusion. The conclusion is true. All cats are animals is a true sentence, but it's true for other reasons. It's not true because all cats are dogs and all dogs are animals. That's not what is now giving you the reason to believe that all cats are animals. But even so, if those sentences were true, they would give you reason to believe that all cats are animals. So that's the difference between an argument being invalid, making the premises true and the conclusion false, showing a counterexample, versus an argument being unsound, the very same substitution set, which you could then go and substitute into these various argument forms to produce a substitution instance, shows that one argument pattern is invalid and shows that the other argument pattern merely has a false premise. It doesn't show that it's invalid. Okay, so let's do another example from the textbook. So another categorical syllogism here. Some farm workers are not people who are paid decent wages because no undocumented individuals are people who are paid decent wages, and some undocumented individuals are not farm workers. Okay. The first thing we want to do is identify the conclusion. That's the most important thing to do at the beginning, and we can see that the conclusion here is pretty clearly some farm workers are not people who are paid decent wages, and the reason for that is because we see the word because right there. Because, and then there's this categorical proposition, and a comma, and the word and then another categorical proposition. So now we need to identify our key. So I will use U, P, and F. So U, I will use to stand for undocumented individuals. And I'm doing that because I'm starting with the premises. So I'm skipping the first sentence. Some farm workers are not people who are paid decent wages, because that's really the conclusion. So no undocumented individuals. So U stands for undocumented individuals. Are people who are paid decent wages. P, people who are paid decent wages. And F standing for farm workers. So now translating that, the first premise there says that no U or P, no undocumented individuals are people who are paid decent wages. The second premise says some undocumented individuals are not farm workers. Some U are not F. The conclusion is the first sentence there. Some F are not P. So now we have the argument's form. We've represented it in standard form, having our premises numbered, indicating which thing is the conclusion. We know that this argument is invalid. That's what we're told. The task at hand is to prove that it's invalid by thinking of a set of categories which we could replace U, P, and F with, and then reveal that the premises are possibly true while the conclusion is false. And it's always best to stick with things that are sort of obvious, at least at the beginning, like, mammals and fish and cats, because you generate sentences which are pretty clearly true or false. Although I have to warn you that with the word some, it's a bit tricky because English speakers and logicians disagree somewhat, let's say, on what the meaning of the word some is. So this, I think, really is going to illustrate that. So here's a way to generate a counterexample. There are always infinite counterexamples out there. This is just one. So let's let U stand for things which are fish, and let P stand for things which are cats, so that the first sentence says that no fish are cats. Okay, so that's fantastic. Now let's let F stand for things which are mammals. Now substituting those into the argument form, producing a new substitution instance. Some fish are not cats. I see I have reversed the order of these premises here. No matter, it's the same. And I do want to focus on that first premise down there, which is really the second premise in the argument form. But remember that this is, I guess, a chance for me to remind you that the order of premises in these arguments doesn't matter, and that what I have written up there on the top and what I have written down on the bottom are really the same argument form, the same pattern. The order of those two premises not relevant to determining what the pattern is. Now, maybe it's relevant to determining whether or not this is in standard form for categorical syllogisms. According to Aristotle, you want the premises in a certain order. But logically speaking, as far as the inference is concerned, the order of the premises is irrelevant. Okay, so now here we have a counterexample. Some fish are not cats. No fish are mammals. Some cats are not mammals. So that shows that the premises can be true and the conclusion can be false. But that first premise is sometimes rejected, let's say, when I say this out loud in class. So when I tell people some fish are not cats is a true sentence, a lot of people will respond with a quizzical look. And they might wonder to themselves, some cats? Some? What do you mean some? Isn't it the case that all cats? Excuse me, when I talk about cats, fish. Some fish are not cats. Let me say my indignant phrase in my indignant tone. Some fish, some, don't you mean all? There, okay, so some fish are not cats seems suspicious to people because they feel like what's really true is that all fish aren't cats, and that it's a bit strange to say that some of them aren't, because it seems to many people as though that implies logically that some fish are cats, which clearly is false. And that's where I was saying before that there's a bit of a disagreement between the way that English speakers hear the word some and the way that logicians define the word some. So for us, the word some is logically equivalent to the phrase at least one. That's what it means to say that some fish are not cats, is to say that there is at least one fish which isn't a cat. And of course, that's true that there is at least one fish which isn't a cat. It's true, in fact, because all of the fish are not cats, that every fish isn't a cat. So, or that no fish are cats. So, in the chapter on categorical logic, we actually learned that Aristotle doesn't like the expression all fish are not cats or all A are not B. He disallows that because it's ambiguous between the two readings, which we won't go into here now. But my main point is that this clash, when people see some fish are not cats and they think to themselves, does that mean that some fish are cats? Well, according to what we have been doing, semantically, it doesn't have that meaning. It has the meaning of there being at least one. But pragmatically, that is, as people use the word some when they go around talking to other people, pragmatically, you wouldn't say this weaker statement, some fish are not cats, if this stronger one were true, all fish are not cats, or that no fish are cats. So this does seem pragmatically to violate some kind of general guideline or something. If you want to study pragmatics, you'd know that Grice would talk about what he calls maxims of conversation, and that one of the maxims is to say relevant things, so that this would be, if the stronger thing were true, the thing that's logically stronger, the claim about every member of the group, then you should say that. So pragmatically, it's a bit weird to say some fish are not cats. But semantically, it just means at least one fish is not a cat. That's true. And it's also true that no fish are mammals. So those two sentences are true, showing that the conclusion, showing that the premises can be true while the conclusion is false. So this is a counterexample. And of course, if you want to say something about the sum and how we interpret that, go ahead and ask. That's why we have the class time that we have. And of course, there's also the comments. Feel free to ask questions. Okay, so let's do another example of a categorical syllogism. So you may notice that all these things are categorical syllogisms. Categorical syllogisms, of course, syllogisms, two premises and a conclusion. They're categorical because every proposition is a categorical statement. A categorical statement is one that asserts a relationship between categories. And Aristotle recognized only 4 of those kinds of things: all A or B, no A or B, some A or B, some A or not B. So we've been over all that stuff before. We're going to switch to non-categorical syllogism examples in just a second. But first, there are a couple things left to say over here. Okay, so no patrons of fast food restaurants are health addicts. Consequently, no patrons of fast food restaurants are connoisseurs of fine desserts, since no connoisseurs of fine desserts are health food addicts. Excuse me, that one got me all choked up there. Okay, remember, I don't write these examples. These ones come from the book, so I don't know why anyone would say this, but clearly it's an argument. The word consequently is there, and there's a bunch of categorical statements. So consequently indicates that the conclusion of this argument is that no patrons of fast food restaurants are connoisseurs of fine desserts. The other 2 sentences are the premises of the argument. So we do what we normally do. We identify the things that repeat. We assign them a variable. So using P for patrons of fast food restaurants, H for health food addicts, C for connoisseurs of fine desserts. So we've singled out those categories of objects. Now we can go back and translate the argument into semi-symbolic form. The first sentence, no patrons of fast food restaurants are health food addicts, now becomes no P or H. Skip the second sentence because it's really the conclusion. It says no C or H, connoisseurs of fine desserts are health food addicts. and the conclusion is that no P are C. So we have the argument now written in standard form. We know what the form of the argument is. We can see it there. And now the task set before us is to think of some way of substituting into P, H, and C a different set of categories which reveal that the premises can be true while the conclusion is false, showing that the original argument is invalid. So this one's, now I'm going to cheat a little bit and just use, I'm not going to write things which are dogs, animals which are fish, or anything like that. I'll just say P equals dogs, H equals fish, C equals mammals. This is technically cheating a little bit, but at this point I think it's okay to cheat a little bit. So, because we've done so many of the other examples in the correct way. So substituting in these categories gives us this substitution instance. No dogs are fish, no mammals are fish, and the conclusion, no dogs are mammals. So it's true that no dogs are fish. It's true that no mammals are fish. It is false that no dogs are mammals, showing that the argument form represented there is invalid because there's a possible way of interpreting it where the premises are true and the conclusion is false, showing that the original argument is therefore invalid because there is a possibility that something with that form could have true premises and a false conclusion. So this is why the definition of validity sets a very, very high bar for arguments. It doesn't merely say that the premises actually are true while the conclusion actually is false. Just says anything with that structure is bad because it's possible that those things are true and the conclusion false. We only want to consider argument forms which never allow that possibility. And there are argument forms that, and many of them, depending on the system and categorical logic, you have two premises and a conclusion in a syllogism. You have four kinds of statements that you can combine into making syllogisms, giving you a finite set of possibilities, and only a subset of those finite possibilities are the valid arguments. In chapter 3 and 4, we can go talk more about that. But for now, let's just continue on. So this another categorical syllogism here. Some school boards are not groups that oppose values clarification because some school boards are not organizations with vision, and some groups that oppose values clarifications are not organizations with vision. Okay, so we see again, this is kind of standard practice. The conclusion is in the first sentence, and then it says this is the conclusion and the reasons for it are these, and we know that is, we see the word because. So we do what we normally do. We find the things that repeat, we assign them a variable. In this case, we'll use S for school boards, O for organizations with vision, and G for groups opposed to values clarification. Substituting those in, leaving everything else the same. Some S are not P, that's an allowable sentence. Some G are not, excuse me, did I say P? Some S are not O. Some G are not O. And then the conclusion, which really was the first sentence, some school boards are not groups that oppose value clarification. Some S are not G. So now we know that this is an invalid argument. We just have to find some way of interpreting S, O, and G, which will reveal the flaw that this pattern has in it. And you can think of ones on your own. It's always nice, I think, you pause a video at this point or at the points like this and then try to do it yourself instead of just having me show you the one that I came up with. But either way is fine. I think you learn by seeing it. If you don't already learn by doing it. So now just taking S for dogs, O for fish, and G for animals. Remember, I'm cheating a little bit of things and so forth, and animals, you should add blah, blah, blah. Okay, yada, yada. This isn't really standard form categorical in the proper highbrow Aristotle way, which you learn in chapter 3 and 4. But it's good enough for our introductory purposes. And so if we use this key and we produce a different substitution instance of the same argument form, so the first sentence, some dogs are not fish. Remember my previous statements about the word some. So what that sentence really means, according to us semantically, is that at least one dog is not a fish. That's, of course, true. Some animals are not fish. That's, of course, true, because that just means there's at least one animal, which is not a fish. So, for instance, a bird would satisfy that. And in the conclusion, some dogs are not animals is false, obviously, because what it says is that there is at least one dog, which is not an animal, and that's obviously false. So now if we've showed that this argument pattern is invalid, has true premises and a false conclusion, and so the original argument pattern is invalid, and the original thing in English, which is a substitution instance of that argument form, is also invalid. Anything that has that structure is known to be invalid because we can generate a counterexample to it. Okay, so let's go ahead now and take one last result. Result. I was reading the word result. Take one last example of a categorical syllogism before switching to some hypothetical syllogisms. Okay, so we have some improvers of humankind are not exploiters of personal information. Okay, as a result, some corporate social networks are not improvers of humankind, seeing that all corporate social networks are exploiters of personal information. Okay, all right. So we have some non-standard indicator words here, which I guess is supposed to be the exciting and interesting thing about this. So we see the words as a result and seeing that. So it says some improvers of humankind are not exploiters of personal information. That's a premise. As a result, some corporate social networks are not improvers of humankind, seeing that all corporate social networks are exploiters of personal information. So clearly the as a result thing is indicating the conclusion here, and the seeing that is indicating that the other thing is the second premise. So if we use I and E for the sort of standard things, I guess I'm not going to write it down. So I would be things which are improvers of humankind, and E, which would be exploiters of personal information. And the first premise says some I are not E. Second premise really is the thing that comes after the seeing that there, which we previously mentioned. So all corporate social networks, you see for that, are exploiters of personal information, giving us all C are E. And then, of course, the conclusion, the thing that is following the as a result, some corporate social networks are not improvers of humankind, some C are not I. Okay, so now we have the argument's form written out for us. Categorical syllogism, two premises, one conclusion. They're all categorical statements. So now what we need to do is generate a counterexample to it, and we know that that's going to be possible because we've already been told that this argument is invalid. In other cases, we won't know already that the argument is invalid, so we'll have to test to see whether it's invalid. Of course, one quick and easy test is to see whether it's an argument form that you already know is invalid. By the way, hint for anyone taking my class, hint, hint, hint. Some of these argument forms show up later. Recognizing them may be helpful for quizzes and tests. Let's say, I don't know, in classes like mine, if you were a student in my class. Okay, well anyway, here's a counterexample, a way of generating a counterexample. If we take I to stand for animals, and E to stand for the group of things which are mammals, and C to stand for the category of things which are cats, then the first sentence, some I are not E, would say that some animals are not mammals, which means there is at least one animal which isn't a mammal. Okay, so fish are mammals, that makes that sentence true. All cats are mammals, that is a true statement about the category of cats. And then the conclusion would be that some cats are not animals. Now that's false because what it says, semantically, what it means is that at least one cat is not an animal, and we know that that's not the case. So showing that the premises can be true while the conclusion can be false shows that this argument pattern is invalid. Okay, so, I see my animations are out of order here. Okay. Oh well, it doesn't matter. Let's just look at the argument pattern there. So now we're going to switch from talking about categorical syllogisms to talking about hypothetical syllogisms. And these are importantly different than categorical syllogisms because they relate propositions. So notice the sentence, if animals species are fixed and immutable, then evolution is a myth. That's a conditional statement. It's an if-then statement. The antecedent and the consequent are specified by my key right here, the A and the E. So A standing for the proposition, species are fixed and immutable, and E standing for the proposition, evolution is a myth. Notice that is not what was happening in categorical syllogisms. In our categorical syllogisms, the capital letters were standing for categories of things which were specified by noun phrases, things which are animals, institutions that collect taxes or whatever. So those are noun phrases, not full sentences. And notice that institutions that collect taxes is not something that can be true or false. It's not a proposition. Whereas species are fixed and immutable is something that can be true or false. According to evolution, by the way, it's false. According to Aristotle, it was true. But according to propositional logic, it's one or the other. And of course, we talked about the law of non-contradiction and excluded middle in a previous section, so I won't belabor that here. But it is really important to recognize that when you see conditional statements like this, the antecedent and the consequent are going to be full sentences, full propositions, so that when you generate your key and you want to tell me what these letters stand for, or tell whoever is looking, if you're in my class, it's me who's looking, but in other cases, it may be someone else, obviously, you want to tell them that it's the proposition that is being related in that sentence. And in fact, those are the only propositions. So the therefore evolution is not a myth indicates that that's the conclusion, and since animal species are not fixed and immutable is the second premise. So now using A and E in that way, the first sentence really just says if A, then E. If animal species are fixed and immutable, then evolution is myth. The second premise says that not A, that A is not the case. And the conclusion is that evolution is not a myth. So that's not E. So this argument, remember this, we know this argument pattern is invalid. This is the one that sort of looks like modus tollens, but isn't. This one is called denying the antecedent, because the second premise, you have denied the antecedent in the first conditional statement. Okay, so we know that this is a invalid argument, an invalid argument even. So what we need to do is prove that it's invalid. And the way that we do that is by trying to think of things which A and E can stand for. In this case, they have to stand for propositions, full sentences, and we have to substitute those in, generating a substitution instance of the original argument form where the premises are true and the conclusion is false. In this case, it's not that difficult to do. Or maybe it is difficult. Okay. So suppose that we use A for the proposition that George Washington was assassinated, and we use E for the proposition that George Washington is dead. Then we could translate those previous sentences as saying that if George Washington was assassinated, then he is dead. That is, of course, a true sentence. If someone is assassinated, then they are dead. Second premise would now say that George Washington was not assassinated, which is true. He did not die from assassination. And so the conclusion would be that George Washington is not dead. Now, of course, unless you're some kind of really big conspiracy theorist who thinks that George Washington is hanging out with Elvis and Bigfoot, never telling a lie and stuff like that, then we know that he is dead. So the first two premises are true. The conclusion is false. We have now shown that the original argument pattern is invalid. So even though we're not doing Aristotle's kind of logic, categorical logic anymore, we're now sort of switched to propositional logic, which is the subject of chapter 5 in our textbook, and really what this class is really about, which we'll be getting to in the next sections. But we switch to propositional logic now, but the same method works. So the definition of validity is the same. A valid argument is one where it is impossible for the premises to be true and the conclusion to be false. And that applies not to the stuff in English, but to the argument form. So the claim is that that thing right there, if A, then E, not A, therefore not E, that it's impossible to make those premises true and the conclusion false. And of course, what we have just seen is that claim doesn't hold up. It, in fact, is quite possible to make the premises true and the conclusion false. In fact, we have done it by producing a counterexample, proving that that argument form is invalid, and proving that any argument in English or in your thoughts that can be interpreted as having that argument form, as really having it, is itself invalid. Now, there's a special note about how do you know when an argument really has an invalid argument form, and I will save that for a later discussion. If you're interested in that, certainly you can ask questions about it. It's a little bit advanced, technical, but important. Okay, so let's take another one. If energy taxes are increased, then either the deficit will be reduced or conservation will be taken seriously. If the deficit is reduced, then inflation will be checked. Therefore, if energy taxes are increased, then inflation will be checked. Okay, so clearly this is a hypothetical syllogism, two premises and a conclusion. They're all hypothetical statements. This is a pure hypothetical syllogism of some sort. So the conclusion, therefore, if energy taxes are increased, then inflation will be checked. So we need to generate a key. How many propositions are there in this statement? Well, there's energy taxes are increased. I'll use E for that. There's the deficit will be reduced. I'll use D for that. There's conservation will be taken seriously. I'll use C for that. And there's inflation will be checked, using I for that. Now, if we go back and translate those sentences then, replacing the propositions with our variables, the first sentence says, if E, then either D or C. We will learn later that these are clues about how to translate this in propositional logic. But for now, let's just leave it as that. And the second sentence says, if the deficit is reduced, then inflation will be checked. That's if D, then I. And the conclusion that we're told follows from this is, if energy taxes are increased, then inflation will be checked. Uh-oh. So my animations are again all messed up, revealing my ridiculous counterexample before it is too, before it was required. Okay, well, anyway, we know that this argument is invalid. So again, we've been told that it's invalid. So we just need to think of a way of thinking of E, D, C, and I, which reveals that the original argument pattern, the form, is bad, and therefore the original thing in English is also bad because it's an instance of the bad form. So a little bit harder with the either, but not really. So if we just use Tom Cruise as a man to stand for E, so E stands for Tom Cruise as a human being, as a man. D stands for Tom Cruise as a mouse, and C stands for Tom Cruise as a human being. Oh, I see. So Tom Cruise is not a man as a human being, as a man, not a woman. Okay. So is a male, I guess, is really what E stands for. Tom Cruise is a human being, and Tom Cruise, has a tail. Okay, so if we use that substitution instance, remember, I'm not making this stuff up, folks. This comes from the textbook. So if Tom Cruise is a man, then he is either a mouse or a human being. Notice that is a true sentence. It is true that if you're a male, then you're either a mouse or a human being. It's also true, I don't know who Tom Cruise is. If Tom Cruise is a mouse, then Tom Cruise has a tail. And of course, the conclusion that follows is that if Tom Cruise is a man, if he's male, then he has a tail. If he's male, then he has a tail. Of course, that's false. It's true that Tom Cruise is male. I'm assuming that it's false that he has a tail. I hope the Scientologists don't sue me because of this. I hope the textbook picks better examples. But it's clear that human beings as such aren't born with tails. You can be a male and not have a tail, so that the premises are true. It is true that if you're a male, then you're either a mouse or a human. In this case, he's a human. It's also true that if he was a mouse, then he'd have a tail, and therefore the conclusion is false. So that shows the original argument pattern is false as well. Okay, so that's a slightly more complicated example, but of course there are many other counterexamples that you could substitute into there and show that the argument was invalid. So let's do one more, because this one is a bit more complicated and it's going to illustrate something which becomes important later in the subsequent chapters. So the argument says all community colleges with low tuition are either schools with large enrollments or institutions supported by taxes. Therefore, all community colleges are institutions supported by taxes. So notice that it looks like a categorical syllogism, has words all in there, and clearly it's an argument, there's the word therefore. But how are you supposed to translate it? It looks a little bit like the previous sentences where it said if and either, and there's all kinds of complex stuff in there. So if you were thinking in those terms, you might generate the following key, and you might say, aha, well, there's community colleges, that's a category of things which are community colleges, and then there's also the category of things with low tuition, schools with low tuition. And so maybe what that first sentence right there is saying is that all C with L are either S or I. So we really keep sort of in line with what we were doing with the hypothetical syllogism in the previous example, keep the structure that's there evident. And then, of course, using that very same key there, the conclusion would be that all C are I. So that's clearly an invalid pattern of reasoning. It's a little bit hard to think of a counterexample, but it's luckily not that difficult because you could take this one. All cats with fur are either dogs or mammals. Okay, so that's true. And then, of course, the conclusion is going to be that all cats are dogs, which is false. So that shows that this pattern of reasoning is invalid. But there is also a way of seeing that really what that sentence up there says, the first premise, is that it just says that all something are something else. And we could equally well represent this argument as having that form as well. So which form an argument has is going to be dependent on how you carve up the sentences, the propositions that are in the argument you're examining. And of course, the most crude way to do it is just use different letters for every sentence. So this could say, we could use premise 1, A, conclusion, B, and say A stands for, all C with L are either S or I, and B stands for all C or I, the actual English versions of it. And so that would be not a great way because you lose all the structure in the sentences that you're examining. But here's another way of thinking about that very same argument. And you might say, well, look, I'm just going to use C to stand for community colleges with low tuitions. That's a group of things. There are community colleges, and then there are community colleges that are expensive and community colleges with low tuition. So that's a perfectly fine group of objects. And then you could say, well, look, here's a more complicated group of objects. It's disjunctive. Things which are either schools with large enrollments or institutions supported by taxes. So you can certainly identify that as a category of things. Is it a real object in the world? Well, you can debate that. There are actually people who might say yes, and there are people who might say no. But the point is that certainly is a way of grouping things together, and we can do that if we wanted to. And then the premise would simply say all C are E, and the conclusion we would now need. I see. I don't have my. We would need I to be just institutions supported by taxes, and that would say all C are I. And clearly, the claim that all C are E is unrelated to the claim that all C are I. So that one may be true and the other could be false. That's fairly easy to show, as for instance, all cats are mammals is true. The conclusion, all cats are dogs, is false. So in this case, and this could be done with any kind of argument that you find, there are always multiple ways of representing what the structure of the argument is. If there is a way of doing it which shows that the premises can be true and the conclusion is false, then it's possible that the argument has an invalid form. Of course, the tricky bit, which I said I would say for later, is that if there's ever any way of representing the argument in a way that is valid, then we simply say that that argument has a valid argument form and not an invalid argument form. Of course, with this one here, there's no way to do that, and so we don't have to worry about those subtleties at this point.